Pick up your colored pens, put your pencil down. Number 1, I'm asking for an equation in function notation that represents the relationship. What did you get? Start with Garion, Michael, and then we'll go to Isabella. What did you get, Garion?
F of x equals 2x minus 2.
Okay.
X equals x times 2.
Okay. Okay. So the correct function is f of x equals 2x minus 2. Michael, that's the same thing as what you said, except of course we're in Algebra 1 honors, and we don't write x times 2, we write 2x. Number 1 was all about perseverance. Many of you did very, very well with that. Many of you stuck with it even though you could not find the answer. You kept working at it. That's perseverance. I don't care if you didn't get the right answer. What I care about is the process. Did you continue to forge ahead when the answer didn't present itself instantly? Many of you did. A few of you gave up. And that's the opposite of what is supposed to happen in this room. But we'll get better. We'll come back to number 1 in a few minutes. Let's go to number 2. Solve the equation for y. What did you get? Start with Marcus, and then we'll go to Laurel, and then Amari. Okay? Okay? Okay. Well, you completely misunderstood the question because I'm looking for an equation where y is by itself. And this is something you learned how to do in Chapter 1. And you're going to be utilizing the skill all throughout the day. So, I don't blame you for having a difficult time with it. But what I do blame you for is not saying one word about the fact that you didn't know what to do. So if you just sat there and stared, well, that was a complete waste of your time. But don't worry, we'll get better. So we're going to emphasize number 2. In fact, I'm going to use it as a mini lesson. A mini lesson is when I take an idea that maybe we're not sure about or maybe we don't recall, and we do a quick lesson about it. And I also have to change a couple of things. So using your colored pen, I would like you to rewrite this equation below the warm-up so that now we have the original 4x minus 2y equals 8. Using your colored pen. And so, oh, excuse me. Let me do this over here. So we need to learn how to get from here to here because you have to be able to do that today. Many times. And to be quite honest with you, by the end of this year, going from this to this should seem like a joke to you. So how do we get from right now, I have no clue, to end of the year, wow, that's a joke. It takes effort. It starts right now. If I want the y by itself, what do I have to get rid of? Someone give me one thing I have to get rid of. Yadesh? The negative 2 has to disappear. What else has to disappear? Amir? The 4x. Very good. Which one has to disappear first? Which one has to disappear first? Marcus? The 4x. You had a 50-50 shot and you got it right. The 4x has to disappear. You start as far away from what you're trying to isolate as possible. So we start with the 4x. How do we get rid of it? How do we get rid of it? Adriana?
Divide. 4 by both sides.
Is that inverse? Divide 4 by both sides. We'll get rid of the 4, but I need the 4x to disappear.
4. Divide 4 by.
Is that the inverse? Is the 4x being multiplied by this?
Subtract.
Well, it's really being added. So what's the inverse of adding? Because you guys are getting confused about what's going on. This says plus 4x minus 2y. Your brain should have inserted the plus automatically. So how do we get rid of the 4x, Adriana? Subtract 4x from both sides. Subtract 4x. This disappears, and now we're left with negative 2y equals. What is that? Yasmin? Unfortunately, it is not. Are you allowed to put those two things together? When are you allowed to put them together? So we have a whole bunch of issues that we have to iron out in 3 minutes. Are you allowed to put 8 and negative 4x together? Chanel? Why not? I love the way you said that. 8 does not have the matching variable. They are not like terms. You are not allowed to add them together. So don't. That is one of the most common mistakes. So we need this. Here's something new. So far, everything we've talked about is all old stuff. Here's new. You now have to put the x term first. Negative 4x must come first, plus 8. Let's go. I'm not sure why you're sitting there doing nothing. Let's go. So one new element is that you have to put the x term first, starting right at this very moment. For the rest of the year and for the rest of your math career, you will put the x term first. But we are not done yet because Yudesh told us we had to get rid of the negative 2. So how do we get rid of the negative 2? You already know how to do that. Every single person's hand should go up. Let's go on a little side trip because I got way too many deer in headlight looks. Negative 2x equals 16. How do I get rid of the negative 2? How do I get rid of the negative 2? Now I got hands up. Laurel? Divide both sides by negative 2. So I'm not sure why everyone was sitting there with deer in headlight look when you already knew what to do. That's not new information. Divide both sides by negative 2, but don't do it yet because now I'm changing something. What I taught you before was to do this. And now, from now on, we will never do that again. Now, we have to divide everything by negative 2. And you're going to see why in a moment. The reason we do that is because we want every equation, every single thing we do, needs to be in simplest form. That means all numbers need to be simplified, no matter what. And so this cancels out, and we're left with y equals. But now we need to simplify this, and that looks really confusing. But watch what happens when I move some things over so that it's easy to see. Let's just focus right here. What's positive 8 divided by negative 2? See here, I should see every single hand up. Every single person in the class knows positive 8 divided by negative 2. Cheyenne? Negative 4. So this is negative 4. Now we have negative 4x divided by negative 2. What's negative 4 divided by negative 2? Jesse? 2. But there's an x there. So the numbers divide, but the x doesn't get touched. So now we have 2x. So yeah, when this was all squinched together, it looked confusing. But when you separate things, not so big a deal. Now put everything together. Y equals 2x minus 4. This is something, this is a skill, this is called transforming an equation. You must be an expert at. You are going to be doing this constantly. Luckily for most of you, just because you do it constantly, you'll probably get very good at it. But some of you won't. And some of you are going to have to make extraordinary efforts. That means you try harder, not less hard. So, any comments, questions? Now, going back to number 1. That was all about perseverance. You're allowed to use more than one operation to get from X to Y. But some of you got stuck on the fact that you couldn't find the one operation that would work. Because you guys said to yourself, oh, well, if I subtract 3, that'll work, but didn't work here. And then you couldn't figure out what to do next. You have to play around with the numbers. You have to explore. You have to experiment. You have to try something and see if it works. If you tried nothing, then you didn't do your job. Luckily, most of you did. Any comments, questions about number 1? So we will hit the point. Okay. Today, in lesson 3-4, part 1, we're going to start graphing functions. We have been in the middle of a building process since the first week of school. I've been saying that repeatedly. And to be quite honest with you, every single thing you've done has built up to today. We are going to use almost everything you've learned so far this year, all wrapped up into one question at a time. Graphing takes a lot of effort and it takes a lot of time. It is the nature of Algebra 1 honors. You're going to spend a lot of time doing graphs. One question is going to take you 5 to 10 minutes. You're used to a question taking you 5 seconds. So that's a big shift. So you're going to have to learn how to emotionally and mentally deal with that. Today, you're going to get tired. You're going to want to stop. I'm going to say, okay, now the next part. And you're going to be like, are you kidding me? But you can't say, are you kidding me? You have to say, okay, this I can do. So, there are no new vocabulary terms, there's no new concepts. It is everything you already know how to do all wrapped together. But you have to pay attention to what you're doing. So, graphing with a given domain. We are given an equation and this domain to use with it. There is a 3-step process we're going to go through. 3 steps. Step 1, we want to rewrite this into a different form. And that's what we did, that's what we explored during the warm-up. It's called function form. But don't worry about the name. The important thing to understand is what the goal is. Step 1 is to get the y by itself. So we want to take x minus 3y equals -6, do some work, and we want it to say y equals something. The reason we want to do that is because of step 2. Step 2, we are going to make a table of values just like you learned last time. We are going to make the 3-column table that you learned. The 3 columns were a thin column on the left, a thin column on the right, and then a wider column in the middle. This was the x, and this was the y. What we spent time last time doing was figuring out what goes here. This time, whatever we get here is going to go here. That is the function that we need for the table. So, let's go back to step 1. We need the y by itself. What's the first thing we need to do? And think about what we did during the warm-up to guide you. What do we need to do first, Amar?
Subtract x.
You said that beautifully. Subtract x from both sides. Subtract x. Elementary school line. That will disappear. This is a huge danger zone. This is one of those details. That negative sign stays with the 3y. That's negative 3y. So we're left with negative 3y equals. But you cannot add negative 6 and negative x. They are not like terms. So you cannot add them together. And you now have to, starting today, put the x term first. Negative x minus 6. Now we have to get rid of the negative 3. How do we get rid of the negative 3? Yasmin? Divide negative 3 on both sides. There's only two sides, so we say both. But now instead of doing one long fraction bar and putting a negative 3 in the bottom, we divide everything by negative 3. And the reason is very important. Because of this right here. What's negative 6 divided by negative 3? Okay, Chopin? 2. And so that simplifies to 2. And so now instead of writing this complicated looking fraction, we can say plus 2. But now we need to simplify this. What's a negative x over a negative 3? Well, let's look at the negatives first. What happens when we take a negative divided by a negative? What happens to the whole fraction, Alex? Turns positive. So in actuality, all we're doing is this. Making it all positive. And so that really becomes x over 3 plus 2. And so we have rewritten the function from here into this. Any questions? So that was step 1. A month ago, that was one question. How to just rewrite from here to here. Now we're using that skill here. This now goes right in there. So now you need to construct a table if you haven't done that already. And now the middle column becomes y equals x over 3 plus 2. And now we can make our table of values. We already have all the x's. It comes from this. That's what that is. That is saying, use me for the function, use me for the function. Negative 3, 0, 3, 6. And now we have to take each of these numbers and one at a time plug it in for x and simplify. Then take the 0, plug it in for x and simplify. Take the 3, plug it in for x, simplify. Take the 6, plug it in for x and simplify. So we now have 4 different evaluations we have to do. And that's what the middle column is for. So now we're going to write y equals, now the negative 3 goes in. Negative 3 divided by 3 plus 2. Take 30 seconds to simplify that. Give me a thumbs up when you've got it. Oh, wow, we got some people figured it out already. That was fast. Adriana, what'd you get?
1.
Michael, do you agree with that? Okay, so we have a disagreement. Jesse, what do you think? 1? Yeah, it's 1. Because negative 3 divided by 3 is negative 1. Negative 1 plus 2 is 1. Now do the 0. Y equals 0 divided by 3 plus 2. Simplify that. Give me a thumbs up when you got it. 1, 2, 3, 4, 5. Okay, put your thumbs down. You dash, what is it? 2. Now plug in a 3. Y equals 3 divided by 3 plus 2. Give me a thumbs up when you got it. Good. Keshape, what is it? Laurel, do you agree? Yeah, that's a 3. Very good. Now plug in the 6. Y equals 6 divided by 3 plus 2. Chanel? Cheyenne, do you agree? Yeah, it's 4. Does anyone have any questions on how we got these values?
I know how to do it, but -3, isn't that -1?
Uh-huh. Negative 3 divided by 3 is a negative 1. Negative 1 plus 2 is 1. Okay. If you're still uncertain of yourself, when we do a checkpoint, you let me know and I will come help. Okay, so that was step 1, step 2, step 3. Now we put it all together. There's a hidden column that you guys didn't know about. It's also training wheels, which means that we're going to use this new hidden column today, maybe tonight. A lot of you will stop using it. Training wheels means when you're ready to take the training wheels off, you take them off. If you're not ready to take them off, don't. So here is the hidden column. Everyone needs to add one extra column here, and you need to extend this line a little bit this way. And here is what the extra column is. X, comma, Y. What we actually just figured out is a set of 4 ordered pairs. You take the X, you take the Y, and that's an ordered pair. Negative 3, comma 1. 0, 2. 3, 3. And 6, 4. And so the whole point of all of this work was to get this. That was the whole point. Now, later on, many of you will be able to handle just putting this and this together mentally as an ordered pair. But for now, I want to see this column for today and tonight. And then after that, you can take the training wheels off if you're ready. So the whole point of steps 1 and 2 was to get those so that we can do this. So now that's why you needed graph paper. And I apologize, I should have had rulers out there for you, so let me get rulers out to you quickly. We need straight lines, so if you can't handle doing it by freehand, then use ruler. So you need a set of axes, a coordinate grid. That's what you're looking at on my screen right now. A coordinate grid. And now we use the skill of graphing. We plot each ordered pair. You don't need to number the grid, but here's something I noticed. A lot of my students don't understand how to use graph paper. You're supposed to use the little lines on the graph paper so that you can draw straight lines on them and then you count very easily. So I demonstrate that up here. Make sure you do that on your own paper and in your homework. Because I have students who draw lines like this, and I'm not sure why, like drawing lines here on the graph paper. Like, why would you draw a line there when you have the lines on the graph paper to use? That's the whole point of the graph paper. So let's use the graph paper for what its purpose is. So now we're going to graph the ordered pairs. Negative 3, comma 1. Negative 3, 1, 2, 3, 1. Put a point. 0, comma 2. 0 means don't go to the left and don't go to the right, stay in the middle. Comma 2, 2 says go up. Don't mess that up. Don't think that 0, comma 2 means you put the point right there. That's an extreme, very common mistake, is students put 0, comma 2 right there. That is not what it means. The first number tells you where to go left and right. The second number tells you where to go up and down. Now 3, comma 3. 1, 2, 3, 1, 2, 3. Put a point. 6, comma 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Put a point. And now we have a graph of our data. We have a graph of the function. Does anyone have any questions on how we did this? This is, I cannot overemphasize how important this is. The whole point of this is so that when you do research, when you do studies, when you are exploring the world, you can make predictions and educated guesses at things. For example, do you see how this is kind of going in a pattern? Let's pretend that this is somebody's performance on something, and they're getting better and better at something. Well, maybe I want to predict how they're going to do next time. Would this be a good prediction of how they're going to do next time? Would that be a good prediction of how they're going to do next time? But if I pay attention, I could predict that maybe they'll do like that. Because this is establishing a trend. You can't see that by looking at this. You can't see that by looking at the table up here. You can only see the trend when you have a graph. And so it's used to make predictions. It's also used to try and figure out what happened in between things. If I want to figure out what happened in between here and here, would it make sense to say, oh, I think it happened up there, or it happened over here? It wouldn't make sense. It doesn't follow the trend, but that would be a decent guess. So that's the whole purpose of all of this. This is what people who do research do, and pretty much every career that you can think of, there's research involved somehow. Does anyone have any questions on our 3-step process? Step 1, convert the function into function form. Step 2, table of values and get the ordered pairs. Step 3, graph the ordered pairs. Does anyone have any questions? Could someone tell us why we do not do this? Why don't we do that? Amir?
It's not continuous.
What is it?
It shows their, well, let's say performance again. It shows their performance for that show. It doesn't show it through, like, the length of the show.
That's right.
That show.
And what else tells you that it's not continuous? Something else that tells us. Gary? It's what? That's true. Alex? They're not connected. Well, we could connect them, but we have to know when we're allowed to and when we're not. This right here says it's discrete. This says discrete. There's specific points in the domain that we're given. So it is discrete. Okay? Any comments, questions? All right. Example B. You don't have to write the instructions again, but you need to write the function and the domain. So this time the equation is in function form. So I'm using the f of x notation. I'm sorry, I should have said function notation, the f of x notation. But step 1 says write the equation in function form. Write the equation so that y is by itself. So what do we do? What do we do? Mike? Okay, gather your thoughts. I'll come back to you. Catalina?
Oh wait, y equals x squared minus 3.
Exactly. She said it beautifully. Y equals x squared minus 3. Now, if a mathematician walked in the room right now, they would get very upset with me. But I'll be honest with you, is I understand how the human brain works, and I understand how young people work. And I think it's crazy to expect people and kids in 8th grade to be able to deal with this and the notation and how it works. So my shortcut is to say, every time you see f of x, replace it with a y, and then at the end, put the f of x back. So for now, we're going to just say y equals x squared minus 3, but now I need the y by itself. How do I get the y by itself? How do I get the y by itself? Seriously? 5 people? 6 people? 7 people? Catalina, you're on a roll.
Add 3 to both sides.
Well, if I add 3 to both sides, then the y will no longer...
Well, never mind, the y's already by itself.
Oh, okay, good. Good, the y's already by itself. So step 1 is basically done. Step 2. Step 2, make a table of values using the function from step 1 and the domain that we're given. But now you can make a 4-column table with a thin column, a wider column, and then 2 thinner columns on the end. And the headings will be x, this is a y, this is the ordered pair. And now we know the function that's going to go right here. It comes from step 1. Y equals x squared minus 3. And the domain, the x values, this gets put right here. Those are the numbers that we are being asked to use. So, list them. -2, -1, 0, 1, 2. Take the input, put it in the function, get the output, form an ordered pair. Y equals -2 squared minus 3. What do you get when you simplify that? Give me a thumbs up when you've got it. Okay, I got 1, 2, 3, 4, 5, 6, 7. Good. Adriana, what is it? Do you agree with that, Stacy? Yeah, it's 1. -2 squared is 4. 4 minus 3 is 1. And so we get the ordered pair, -2, comma, 1. Does anyone have any questions on what we're doing? Could we all work simultaneously? Could you guys finish the table while I finish the table? Think you can do that? Okay, go. See who wins. Well, I got a lot of people looking up. Makes me believe that you finished. So the whole point of all of that work was to get this. So give me a thumbs up if that's what you got. Make sure I didn't mess up. Hope I didn't mess up. So I got some people got it. Okay, Chopin, you got the same thing. Cheyenne, you got the same thing. Amani, you got the same thing. Okay, so now we've got our ordered pairs. Now we can go ahead and graph them. So use your ruler and your graph paper and draw a set of ordered a set of axes. And now we plot the points. -2, 1. And -1, -2. 0, -3. 1, -2. And 2, 1. Power of 0, that's not All right, so your graph should look like what I have up here. So, 3-step process. Write the equation in function form, meaning y by itself. Make a table of values and get the ordered pairs. Plot the points, and you have a graph. Does anyone have any questions on the 3-step process? Any concerns? Okay, no questions or concerns. All right, checkpoint number 1, you're going to try it on your own. This took my last class 7 minutes approximately. You guys get 6 minutes. 6 minutes for 3 steps. That's 2 minutes per step. But you know that the middle step takes the longest, maybe? Maybe the first step takes the longest? If you're getting lost, do you have any concerns, please let me know and I will come help you. This here for a moment. All right, now we've had enough time. Pick up your colored pen and find out how you did. I'm going to reveal the graph so that you can see how you did. Here we go. That is what your graph should have looked like. To make sure that you have the correct locations, the correct points, here is what you should have had graphed. 4, 11, 1, 5, -3, -3, and -5, -7. Those were the 4 points that you should have figured out. Are there any comments or questions on how we did this? Okay, We were going to do a second checkpoint, but I've run out of time. That's my fault, not yours. But I want you to see briefly that you will deal with absolute value functions. And make sure you're watching. If you're packing up already, then you're going to have a serious issue. So you're going to see some of these as well. And a lot of people got confused on what to do. But think about what our goals are. Our goals are step 1 to get y by itself. In this case, y is already by itself. So that's it. Don't do anything. Step 2 is to make a table with this and with this. And then step 3 is to graph it. So what's interesting about absolute values equations is how they graph. And so they actually graph not in a line, but they form a V. And most absolute value equations will graph like this. Because the absolute value makes everything positive, you end up with a V because there's a point where the graph bounces back up. Because it's stuck, because things can only be above a certain point. And so almost all absolute value equations graph like this. It'll be a V, it'll just be depending on where the V is. Yeah.
Is it the absolute value is distance from 0, right?
That's
So
right.
So the graph could never be below 0.
It can, but don't worry about that right now. And you're not going to have to deal with that this year. Okay? So draw a line across your paper. Your homework tonight is lesson 3-4 worksheet, which you're going to get in a few seconds. And you're doing 8 questions total. You're doing 1 through 4 and 13 through 16. That's what's on the sheet. That's only 8 questions, but you should have noticed already that one question takes a little time. So if you take 5 minutes to do one question times 8, that's 40 minutes. That's not terrible. And you have a quiz tomorrow on 3-1 to 3-3.